Slowly. Thanks a lot everybody for coming for Java, you guessed it. First Yaroslav will talk about GraphQL, then we will have Ludek talking about design system and an open source library that Kiwi has regarding the design systems. And then last but not least, Michal will talk about open source and stuff that Kiwi did for the community. Okay, that's all about today's meetup, but so I would really like to propose for you, so if you have something interesting to talk about or something like that, just to post it on JavaScript Zagreb GitHub issue page. You can see we have some presentations in the backlog, but there is never enough presentations, so feel free to propose presentation and we will do something about it. Okay, you can also visit javascript.zgb.com, I think at least. Yeah, internet slow. Yeah, doesn't matter. So yeah, feel free to propose any talk. Feel free to hang out after the talk with us, have a few drinks, have some good time and make some connections and talk JavaScript. So I will leave my mic to Yaroslav and his GraphQL stuff.
No? Is it working? Yeah, perfect. Okay, so welcome everyone. Thanks for coming and having me today. And I came to Zagreb from Prague, where I work obviously for Kiwi. And today I would like to tell you a short story. I would like to tell you a short story. So imagine you are living in a simple world on a planet which is actually flat. It's quite simple. It's just disk on top of 4 elephants and 1 big turtle. And there are some silly creatures living with you, and you are working as a front-end JavaScript developer in this world. And many things got improved recently in your world. On your front end, you have currently features that were not possible in recent years. Few years ago, and currently, for example, you can declare your types to have some type safety, so you don't get some unexpected error on production, and it looks really nice and smooth. And as I mentioned, there are also some silly creatures living along with you on a backend, and they might speak the same language as you, but sometimes they speak completely incomprehensible language to you. You don't understand them much. It depends on your environment. Anyway, no matter usually what's the exact language on the backend, there are pretty same things as you have on the front end. So there are usually some types. You can possibly declare some classes, declare your data abstraction, have some polymorphism to the interfaces. You can reference objects between each other. So it looks quite loading. No. Sorry, just a second. It was working just few minutes before presentation. I saw the image. I can. No, it's not. I can join to my so. I can possibly do this as well. Work. Loading is already on 100%. Magic. It should work. Hopefully, it looks like it's. Oh, okay. So yeah, internet. So as I said, if you look on your front end and if you look on a back end, it kind of looks same, right? So what's wrong in this environment? What's wrong with this simple Discord? Well, the problem is somewhere in between these two environments. If you have REST APIs, usually you spend a lot of time and you put a lot of energy into packing your request, forming your request and sending it on a backend. And on the backend, you again need to decode it and understand what a front-end is asking for. And this has some consequences. For one of the main consequences usually is that your front-end has no clue about data model underneath. And you saw that you have types on front-end, you have types on a back-end, but in the middle, in the communication, this information about types, how the data looks, is missing. This information is forgotten, and so usually you spend a lot of energy into handling some possible exceptions when something is missing, or there are some arbitrary standards how to design a REST API with some standards, but it's not something out of the box always need to keep yourself focused on keeping it to some standard, which is, again, as I mentioned, it's quite difficult, and this work is necessary on both sides to avoid having something like on a picture below. So I would like to introduce you to real world, which is not flat, hopefully. So welcome again to real world with GraphQL and possibly with Relay Modern as a library on a front end. So my question right now is, how many of you are familiar or somehow with GraphQL? Raise your hand. That's okay. How, possibly? And how many of you are working daily with GraphQL? Okay, not so many. So for the rest of you, it's something rather new, I understand. Okay, so I start with simple, really fast introduction into GraphQL. It's touching just the surface. Basically, out of the box in GraphQL, you have just one endpoint with the whole schema where you have strong typing. You have types defined, which can be even generated on backend based on your classes, possibly. And you can also declare whether some fields you are asking for are nullable or non-nullable, which means that whether it can be null or not, whether there should be always specific value. And you also have possibility to use interfaces, just like in some languages. And documentation is part of the specification as well. And on top of that, because all this stuff is part of specification, you have possibility to detect breaking changes. Usually in implementation, you are provided with a function which you can use in your continuous deployment. So when you are introducing changes on a server, you can check your new schema, whether there is some breaking change. You may accidentally remove some field. So this can prevent some such unwanted changes. So how this fits together with React on front end, how it fits with the front end. On the front end, you need to probably use some library which is able to work together with GraphQL server. Probably it's either Apollo, which is quite famous, and there is also a Relay Modern, which is what we use because it's more strict, in my opinion, and we like it to have it more strict. So how it looks. If you look on example, I have a really small, simple component. It's component showing the price with some amount and currency. And normally, I would need to define props by myself manually. In the GraphQL and Relay world, I have different approach. I can declare the fragment piece of information I need for my component. So in this case, I need to know amount on currency um, for my component, and that's all. So I declare the fragment for component like this. And the next step I need to do is quite simple. I need to execute this simple command. It compiles all my fragments, all my queries I have in components, and it creates for me some generated code that includes, in these auto-generated files, you have flow types created just for you based on the schema and what you define. So you are provided with such type which you can back import in your component and use it in props. This means your props always match what's in a schema, what's currently on a server, and what you can ask for. And on top of that, you know, stuff is changing a lot. So what can easily happen is that I remove a line that is showing the currency. And the code would be still valid, but I don't need to ask for currency anymore, and I can forget about it in my fragment definition. So I can also set up my linter to check for such things. So in overall, I'm quite excited. I don't know about you, so I am the only one. If I am the only one in the room excited about this stuff, I'm probably a very bad speaker. And I need someone else to describe it in short, in such short talk, much better. So this was just a brief introduction into possibilities you have with GraphQL and Relay library on the front end. And now let's move on some more interesting stuff. Of course, let's look on kiwi.com homepage. Obviously, what you can expect on such website is possibility to search for flights and make some booking. So let's travel around the globe. As you can see on such page, you can go just from one place to another. You can also go on vacation, and then you want to come back because you want to build some stuff again after vacation, hopefully with GraphQL. Or you can travel from place to place. You spend a few nights in some city, and then you travel again to some new city. That's what we call multi-city. How it looks on our page. You can see these three examples. The first one is simple travel from place A to B, in this case from Barcelona to Porto. Then you can, as I explained, you can travel between more cities. Basically, it's list of one-way ways in one booking. So you travel from Barcelona to Buenos Aires, you spend some time there, and after a few days or just one night, you travel to new city. And of course, a return flight is your plan where you plan to go back, probably, for example, on vacation or something like that. So the question is how you would represent such data in your REST API endpoints. You would probably define something like type, and then based on type you would check some fields in a response, because it differs quite much. In one way you have just one trip. In multi-city it's a list. So would you return in first case just one item, and for the second case would you return a list of these items, and you would then check in your code and based on that decide which type is it. You would definitely need to write some logic. So with GraphQL, you can do something which is already in a normal programming language, quite common, some type of interface. In this case, you can start by defining common fields, what's there every time for each type. It's something like ID, number of passengers, that's shared across all these types of bookings. So you declare your interface that has all these common fields, and later you can define one concrete type for this interface, for example, booking one way, that again has all these common fields which are defined in the interface, and on top of that you can provide more fields that are specific just to this specific type. Is it somehow understandable? If you there is nice feature about it because it's all declared. So when you try to run the server and then you forgot to declare that this object is implementing this interface, and you forgot about some field in this interface, it crashed. So you are also safe in this field that it crashed sooner than you send some request to it. And then there are graphical tools, for example, GraphQL Playground, where you can see all the documentation. You can check GraphQL Kivicom, which should show you this playground, and you can search for booking interface, and you can see that it has this implementation, and you can then check individual fields and what to ask for. So short demo time. Basically, this is my query for the booking, and I'm asking for the type of the booking, and then for specific fields for each of these types. So in case it's just one way, I'm asking for this one item for the departure and arrival. I use fragments to make it shorter, so I reduce these definitions. So fragments are actually not something from relay, but it's really part of specification of GraphQL itself. So even if you use Apollo, I recommend you to use fragments a lot. And if I send such query on a server, I get back some data. I get information that it's one way. So all fields I ask, in case it's booking return, such fields are not even in a response because they are irrelevant for this type. So I know that it's booking one way and that I am flying from Ponta Delgada to Beno. And last piece of information on the front end, then you check for the type, and based on the type of booking, you can render the specific itinerary. So in one-way trip component, you probably have fragment defined for one-way trips from place 1 to B with all necessary display logic and all data you need to display such information. So in case it's one-way, you can one-way trip, you can display such component. And again, you can see that I use some flow type, which is probably auto-generated again for me, and I don't need to write something by myself. So that's basically it. What I wanted to show you, some possibilities, how to use interfaces on GraphQL. It may come handy. I find it quite as a nice, one of nice features you have in GraphQL. Basically, if you start writing some GraphQL, you shouldn't do it like you are writing some REST API. You should design your schema based on your design. So all how it looks on a server should more or less be based on your UI. So it's easy for you to define the fragments, and then you can even build some library and show these components on more places. Because in our case, we have something like this in search. Then we have some place like manage my booking, another place on the website where again we show you exactly these information. So you would need to normally re-implement this stuff from scratch every time. If you even put it further and develop some shared library which has these, which already contains these fragments defined for you, you can just plug it into your application, and then even you can reuse it, for example, in mobile applications. So you already have three places where you can reuse such fragment components. And then it all looks like big puzzle you are building. So my message, basically, don't be this guy. REST API works, and it's probably fine, but many times as the project is growing and the complexity is rising, it reminds later more some old post office on a horse, where you always need to spend a lot of time on packing all the letters and going on a horse somewhere, and then someone on other side needs to unpack it, and some information is maybe lost on the way, like types, for example. So that's my message, and thanks for listening.
Okay, do we maybe have some questions for Yaroslav? Okay, no questions, so, okay.
So you said, so you said that backend should reflect its structure based on UI, right?
Yes,
to
exactly.
use this. Okay. So what happens when we decide to like redesign our application? Do we need then to do this on backend as well?
Yeah, basically you should start designing your server after you have already some knowledge of how UI will look like.
Okay, I understand that, but
Yeah.
like there are some cases like with new products, new companies, when they design something and then from the feedback of their users, they realize that it needs to look completely different. So then the problem becomes we have like double job to fix this, because we need to fix the front end and the back end. So
such things are happening. I was rewriting our queries on GraphQL a lot during the year. Basically, you can introduce your new fields, new queries, and you can move onto these new queries and new fields which are adapted to your new design, and the old fields can be deprecated. That's also part of the specification. You can declare that this field is deprecated. So if some project is lagging behind, they should notice that they are asking for deprecated fields. It can be logged. You can see it in logs. That hey, and then you can contact these guys. Say them, hey, we changed the design. You should do it as well. So later you can actually do the break-in, allow to yourself to do break-in changes on the server by removing the old field.
okay, thank you.
We have another question.
So at the beginning of the presentation you had an example of server where classes and interfaces almost presume that you already have all the values in status, right? Do you start, when you start structuring the data, do you start from the database? Because you had classical SQL database, it doesn't really look that much like the outcoming JSON. Did I make it clear?
What's the exact question?
Okay, so I'm wondering, where do you start? Do you start designing data structures from the database or from the interface?
From the interface. And then it's the exact opposite, as usually in REST API, you start on an interface level, and then you have a resolver for possibly every field. So, which means that if you need to do a lot of queries to database, you can, on a root, you can fetch just one table. And then only if you ask for this additional field, which needs to be fetched in another table, you can send in a resolver another request to database. And then you can start solving some performance by introducing some caching mechanism or something like that.
Okay, thanks a lot, Yaroslav. We need to continue. One round of applause for him. So next one will be Ludek. He will talk about styled components or styled systems, in particular Orbit that he developed. Okay, let's continue, guys. Yeah, you can start, I think.
So, hi guys, I'm Luděk, and I'm going to talk about building design system components with React and styled components. Firstly, let me introduce myself. My full name is Luděk Vepřek. It can be quite difficult to pronounce, maybe for you. I work at Kiwi.com as front-end developer. I'm a member of front-end design platform tribe, so I focus mostly on developing our design system called Orbit. And I've got probably 6+ years of experience with design and front-end development. As being part or member of front-end design platform tribe, I care probably the most of the developer experience of our front-end developers, and maybe Honza, our Orbit lead, is caring about some designer experience in Sketch. But for us, it's the same thing. It's very important. But firstly, what is developer experience? I think that most of you knows what user experience is, and the definition said that user experience focuses on having a deep understanding of users and their needs, abilities, and what they value. And I think that the same definition can be used for developer experience. You just need to switch the words, developer and developers. So developer experience focuses on having a deep understanding of developers. But what actually is developer experience in real world? In real world, it can consist of many things, but I like this definition that developer experience describes experience developers have when they use your product. The product can be framework, library, open source tool, API, etc. And why developer experience matters for us, for our team? Well, it's simple. Because developers are human too, so it matters for the same reason why user experience matters. And also, if you have a good developer experience, it means that you're gonna have happy developers, and happy developers are efficient one, and you need and want efficient developers in your company. But in the end, in the real world, what developer experience can consist of? Well, it can be your technology stack, your setup of CI pipelines, and also many, many other things. For front end, we can just simply ask two main questions. What is your developer experience when it comes to developing user interface, and also do you need to develop your components that you're gonna use in your project? Well, if I answer for this question, back 2 years ago, there was no system and it was pretty chaotic. I call this problem atomic problem because every atomic piece of the user interface was not unified. It was developed many, many times, and the button is living proof. Why? It's simple. The button was probably made or developed probably 50 times. It cost the company a lot of money and also a lot of time for the developers. And also there was so much inconsistencies between the actual design and the actual front-end part. And also it was very hard to change it because you just didn't know where the button is used in which and what cases. So it was impossible, and you rather develop a new button for you because it was the most simple solution. So we had this problem, or these problems, and 2 years ago we just came with idea to have a design system. So we started with that, or not me personally because I was not at Kiwi.com yet, but we have a design system called Orbit. But firstly, do you know what the design system is, or how many of you know it? Raise your hand. Okay, so 3, 4 guys. Okay. So design system is a single, or the single source of truth, which groups all elements that will allow the teams to design, realize, and develop product. So it can consist of Sketch UI kit, components in React or Vue, whatever, and also some design-made choices that are called design tokens. Design system is also common ground for all job roles: designer, developer, QA tester, maybe even biz dev people. And why? Because everyone, when you are using the design system, you're talking and using the same language. So let's take an example of the button. The button has the same name and the same properties and settings for the designer and developer, and you can easily identify what button is and what option it has. So, design system component library. Like 1 year ago, there was no components in React or some other framework. There was just a Sketch UI kit that designers used, and a lot of front-end developers just was trying to develop components for their projects or use cases. But then we came up with the idea, okay, we should have probably some components library. So we created a public repository on GitHub. It's under Kiwi.com organization. It's called Orbit-components. Yep, that's it. And before we just started to develop components, we needed some guidelines or principles, how we actually gonna develop those components and what the process is gonna be. So for some principle, we just looked at the developer experience and said, okay, so developer experience consists of 4 key points. That is function, scalability, stability, easy to use, and clarity. Function is there for the expected behavior and features. Stability is there for no breaking changes, or if so, there should be documented and it should be consistent. Easy to use means some proper documentation and also some principles for the API. And the last one, clarity, me personally, I consider this the same as easy to use, because when the product that you develop is easy to use, the clarity is secured. So I think that easy to use just clarity also. This is described by the Maslow's pyramid, but this is based on minimum valuable product because you need to deliver those 4 key points at the same time. So when we're gonna develop button, the button has need to function. It also needs to be stable, and it needs to be easy to use. So therefore, there is the blue line on the right part. On the left, sorry, for you. Okay, so now let's take a look at how we actually develop it. For developing or for the technology, we went fully with React because most of the projects are using React. And also for the styling part, we choose style components because it's the probably the most used and the most popular framework when it comes to CSS in JS. And also, we are trying to have some lean approach when it comes to developing new features. So we develop features and components only upon some request from designer or developer. And it means that it would be totally useless to make some component utility or feature that is not going to be used anywhere. So it's just totally useless. We are also dependent on the atomic design. This is from one book that is called Atomic Design. It's from Brett Frost, and its principle how to make some easy decision what is the most general part or the most atomic and what's the biggest. And it's heavily used for UI kits. So I think that this can be also applied in React component because we are just developing atoms and molecules because atom is the most atomic component. It can be icon, button, text link, and whatever. And then molecules are just more complex components. It can be some card or module, and it can consist of some other subcomponents. The organism templates and pages, we don't provide any components for it because it's too complex, and those 3 categories should be used only in the final implementation in some project. We've got also documentation for our entire design system. It's publicly accessible on orbit.kv. It consists of some guidelines how to use our colors, icons, illustrations, and also it contains API documentation for every component. So, for example, for every component we have a markdown file that contains every property and that is described, and also some functional specification or accessibility guidelines if it's necessary. So let's talk about style components for a brief moment. As I said, I think, or they are taken like the best solution when it comes to CSS and JS. And it's meant to be a successor to CSS modules, and I think that the team behind style components is doing a pretty good job. And style components are allowing us to write plain CSS in JS files. So, and also we don't need to care about class names, so there are not class name collisions, etc. And also, because it's plain CSS, there are many features out of the box, like the native CSS, maybe less or SCSS. So vendor prefixing, nesting, pseudo elements, media queries are supported out of the box, and also we can use some conditional rendering, some mixins or functions. And there is also basic support for React Native, just like Vue and maybe another component. But it's really basic, and I don't think that it can be used for a big React Native project. So this is quite a short example, but we can see that we are defining a button that is actually styled div, like my mistake, because it should be button. But the declaration of the CSS is done with backticks, so it can be quite confused for the first time, but it's native JS function because it's tagged template. So all the CSS declarations are in reality arguments that are passed to div function. And also another interesting part that you can see in the example is that we are using some theme property. And it's heavily, I don't know the word. It's therefore because we need to support some visual changes quickly and also some branding for our business partners. Actually, there are like maybe more than 30 business partners that we have at Kiwi.com. So this is another requirement, and also we want to make design changes quite easily. But how can we do it? We can do it with theming context that comes from style components and React, and also with design tokens. Maybe you heard this term for the first time, but in the end, design tokens are just stored variables that contains design choices that we made a long time ago. So it can be font sizes, spacings, colors, etc., etc. Like everything that anything can be design token. In practice, the button can consist of many tokens. For instance, we've got some generic token like font family and also font weight. And then we've got component-specific tokens. It can be background button primary or font size button normal. So there's some property in the token name. Okay, so we've got tokens, we've got theming in our repository Orbit component, but actually how we can change the look of the components easily, it's pretty simple because we are providing a function from Orbit design tokens. It's called getTokens. You're just gonna pass one argument, that's an object that contains foundation definitions. Like here we can see that we want to override colors, product colors, and especially light, normal, dark, etc. This function is gonna return us object with tokens, and we just gonna pass it to the theme provider from style components. So it's pretty easy. Also need to say that out of the box, style components doesn't support right-to-left languages, so you need to do some other way, and we're just using some functions that are converting some position properties, like it converts left property to right property automatically if the RTL is set to true. In the end, this offers us a possibility to support many visual brandings and also make design changes quite easily. So we can redefine the whole colors, the border radius, font size, letter spacing, etc., etc. Heading to the end. So what does design system offer us? Well, we can, for instance, improve whole accessibility of Kiwi.com products. We can also make the entire user interface much more consistent because the components and the guidelines behind them, they just gonna have pretty good UX patterns in it. And we also can make the visual changes quite easily and also support the visual branding. As I said, the repository is publicly accessible on Orbit components, so just don't hesitate and try to look at it. I think that we've got a pretty good sort of component that you can maybe use. And if you're gonna like it, just give us a star and I would very appreciate it. Also, the documentation page is available on orbit.kv. So that's it. Thanks for your attention.
Okay, thanks a lot for the presentation. Do we maybe have some questions? Okay, we have.
Have you already? Oh, yeah. Have you already tried to use this to change the styles of the components, or just?
Sorry, once again, because I was listening to the guy here.
Okay.
Sorry.
I got a question. If you already tried to implement to change the styles of some components, because as far as I know, Kiwi looks the same for a couple of years.
Like in 6 months, most of the changes were like some color tweaking or playing with some hover and active states. So in the end, we didn't made any major like breaking visual change, but there is plan to, and in the end, we're gonna see if we have the teaming done properly or not. Because in practice, it won't work because it's only theory behind it. Like this is problem that every team has, because it's quite difficult to determine what tokens or properties you actually need.
Okay, any further questions? Okay, thanks a lot then. One more round of applause for him, please. Okay, Michal, let's talk some open source and JavaScript in general. This is the big boy's mic.
I think no, I will use this one. Yeah? Yeah. Because it's very silent. Yo, nice. Exactly, like it's too loud. Good evening, everyone. My name is Michal. I work in Kiwi.com in our Prague office. My role is principal engineer, so I have a wonderful opportunity to push cutting-edge technologies like GraphQL, React Native. What else do I push? All the monorepo, of course. I will slightly touch monorepo. Wait a few minutes. And this talk will be, and I push also stuff to publish as much as possible to open source. That's what my talk is going to be about. And as we are doing a lot of around GraphQL, so mostly we will talk about our open source tools around GraphQL. Before you start using GraphQL, you should set up your project. So first thing I want to mention is our ESLint config. It has it has support for all the technologies that are listed here, and you can save a lot of time just by yarn add and start using it. The config is pretty simple, so that's basically what you have to do. If you start using it later, you probably get a lot of issues, but it's very worth to fix those. And I believe not every project has to be built on Airbnb ESLint that is widely used. Our ESLint config is more strict, but also supports things like Prettier and Relay. So if you are on this dev stack, our ESLint will helps you a lot. The package also comes with ESLint runner that fixed issue we had with the time, because the ESLint took quite a lot of time on bigger projects. So we incorporate a jest and let a jest run the ESLint. So we have parallel execution. We check only the files that were changed, and we also automatically fixed what's possible to be fixed. And it basically looks like this. So you see the yellow bottom lines, 3 tests run in parallel, because I have only 4 cores. So if you invest like 1,000 euro more, you can run like 8 tests in parallel, and that speeds your development pipeline. We also published a Babel preset, so you can start using all the syntactic sugar, flow, class properties, and most importantly, relay fragments, which is one of the biggest features of GraphQL and relay on front end. So once again, Yarn and Dev are Babel preset and start using all the nice features of modern JavaScript. We published also our version of a fetch that adds features like retries, timeouts, and better error handling. Why we need that was this. We started to use GraphQL this way. We had a REST API backend services, so we just create in JavaScript a GraphQL proxy that so clients could communicate with GraphQL. There were no changes on the backend needed, but we had the issues that the REST APIs were unstable, so we implemented those retries and some timeouts to be built in. Very handy. It's used like this, just a few more configuration, a few more options to standard fetch options. Basically here you can see after 15 seconds it's timeouted, and if it fails with some 500 error, for example, we try it in 1 second, and if again we try it in under 3 seconds, and then we give up, because sometimes the REST API is that unstable. And it increased the user experience. Just don't give up on the first error, try a few more times, and maybe it will succeed. The work with errors is described in this code snippet. So you can see that your front-end code can react properly on a timeout or some other errors, which can be useful for user experience. When we were running the GraphQL backend, basically, we were also in a need to have some monitoring. So we open sourced our solution that was built on Logs.io service, because the like standard Apollo engine became very expensive for our traffic. So we just create this library that sends metrics like query duration, headers, variables, information about if there were any deprecated fields, and we just can see the stats and real-time monitoring in a Logs.io dashboard. So that's pretty useful, because you can also attach some PagerDuty and these tools if something goes wrong with your GraphQL backend. Here you can see, or slightly see, the detail of the record. So we log everything we found useful. You can extend it. We are currently migrating from Logs.io to Datadog, so next major version of this tool will support Datadog. We got a script that checks if there are any BC breaks in our GraphQL schema. That's very handy, because ideally you don't want to introduce any BC breaks in your schema. So this script checks if something like that happens. It's focused on a developer experience, so if there is any error, there are suggestions how to do some workaround not to have the BC break. Or if you really force push the BC break, it creates a log of the BC breaks, so you can do some automation around that, like inform your users, yeah, sorry we introduced this BC break, please figure out what to do. And we of course version this snapshot, so it just grows. as we are heavy dependent on Relay, and we think it's a great front-end framework for GraphQL, we want to help others to work with it, because the Relay has definitely bigger barrier to entrance this framework. So we create our own package where we make better developer experience with support for logging and some response caching, batch requests, and all these things. Also proper support of flow, because there were some issues. So we published the package. And here you can see how just the simple logging in Chrome Developer console looks like. So that's very handy during development. You get insight into what's happening. And when we introduce this package, we also introduce a Relay example on a GitHub. So it's basically a how-to for that previous package. So you can learn from code how to do the simple fetching, how to do endless pagination, or bidirectional pagination. Basically, check out the repository and dig into the code, and you can, in 5 minutes, easily get the idea how to work with Relay, and hopefully you can then have better decision about, shall I use Relay or shall I use Apollo? The simple example application looks like this. As you can see, it's using Orbit, because there is no better design system available currently. And we are using only the best tools, of course. And the data, the list of these locations comes from our public GraphQL backend. So you are working with real data, and it should be really easy to play with this, the project. We also did an internal workshop about Relay. We record the talks. So if you want to dig into Relay, part of the Relay example documentation are also links to these videos. So hopefully this will also help you to learn and understand the Relay principles. And the biggest open source project we have right now is Project Margarita, which is like a reference implementation of our backend API called Tequila. So we add few more ingredients to Tequila and create Margarita. So the Tequila API gives you backend for searching and booking and manage booking of the itineraries Kiwi.com provides. So you can easily build your own Kiwi.com clone or integrate some travel features in your project. And we built Margarita as a showcase how to do all the front-end stuff the cool way. So we have GraphQL and Relay, and most importantly, the shareable UI, because we are also trying to support a mobile application with React Native, and we didn't want to do special components for mobile and separate components for a web. So we are experimenting with a React Native web. All the components are written in a React Native, and with React Native web rendered on a web version. I think this is very huge, and if we succeed, it will be a huge step forward, because then one team of React developers can deliver features on 3 platforms, web, iOS, and Android in the same time. That's gonna be huge. Check the project on the GitHub, and this is basically how it looks like. Yeah, it's working. So this is the web version, like simple Kiwi.com homepage with a search form where you enter from where and when, and you receive the results. So these components are written in the React Native, but on the browser rendered at standard HTML. Now you can see the Android version. Few UI is different because the platform needs it, but still these are the same components that you saw on the web. We also have some manage my booking feature, and that's basically it. So the huge thing here is one component that can be rendered on multiple devices without any compromises. If we want to have special component for iOS, we can still make it. So these are the open source tools, and I also want to mention how we are developing these things. So we are experimenting with a monorepo approach. Is anyone here already using monorepo? Nice. Why we are trying to have a monorepo? Because we want to do the fast iteration across all our projects, and we want to have these projects consistent. And in our incubated tribe, we create a lot of new projects, and the first 1 or 2 weeks were always set up CI, set up flow, set up all the standard stuff, and over the time you do the things a little bit different. So the project that started 6 months ago is different, has different setup than the current new project, and we are wasting a lot of resources on this. So we try to incorporate Yarn workspaces and do the folder-based monorepo. So one project in one folder, and maximum of the setup things can be shared. Currently, the monorepo is almost 300 megabytes. It's growing, and it still works well. All the support scripts we are using, for example, to iterate the workspaces, are published in the KiwiCom monorepo package. So if you are about to start using monorepo, try this package. In the monorepo, we are also developing all the open source projects, and the way how we move them from the private GitLab monorepo to the public GitHub, we have built a project called ShipIt, which basically can take the project from its directory in the monorepo, do some code transformations that are needed, and migrate it to the GitHub. If some changes happen in GitHub, like someone creates a pull request for us, we have a tool called Imported that just takes the pull request from a GitHub and creates a merge request in our GitLab. There we do all our necessary things that we want to do. We merge, ideally we merge the merge request to our private code, and with ShipIt, mirror it back to the GitHub. It's heavily inspired how Facebook is developing their open source projects, and they also have ShipIt, but that's written in a hack. So we rewrote like the functionality in a JavaScript, and of course we make it public on our GitHub. The ShipIt config for the project is pretty simple. You just define your GitHub organization, name of the project, and then you can define some transformations. On the first line, you can see that we have a dedicated flow config for the relay example, and during the publishing, it's copied to the root of the project. Of course, in the monorepo, it has to be in a separate directory, because the flow config for whole monorepo is totally different, and we can do many other transformations during the publishing phase. So that's basically it, how we work with open source. I think everyone here heavily depends on open source. So if you can do at least something small, please start the libraries and projects you like and you are using. It's great. It's the smallest and very great benefit for the developers working on open source. Create the issues if you find some problems, because that's a very valuable feedback for the developers. And through the issues, the tools can be better. So for example, try our ESLint config, and if something doesn't work well, don't just say, it's a crap, please write to us. It's a crap because I'm missing something, and we will try to find a solution for that. Or if you are really like brave enough, make a pull request, and we will probably send you a bottle of vodka or something, because that's really rare to have something like that. All the links, to all the projects I mentioned are on this page. I will share the slides, so you can check it. We have even more I didn't mention in the talk. For example, how do we publish the NPM packages? Again, we have some package for that, and we publish it. So if you want to learn something about these things and basically all the cool things around JavaScript, at the end of May of the next month, here in Zagreb, we will organize a JS weekend. So please register, and we will spend from Friday to Sunday 2.5 days on, or 2 days on a workshop. We will teach you a lot of cool things. We will buy some drinks to forget everything, and basically we can enjoy a good time with JavaScript. So this is the web where you can register, and that's it. Thank you very much for attending. Maybe there are some questions.
For Michal, maybe? No? Everything's clear? Okay, that's good. Then thanks a lot, guys. Let's continue our gathering in Pivnica Budweiser, so it's just down the street. So feel free to join us, have a few drinks, have a few questions for the presenters, or just hang around and talk JavaScript and meet new friends and figure some new stuff out. Thank you. See you next month, I think.